Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 13, Section 4, Part 4, and 13.4 is about acid-base reactions. And that is also called a neutralization reaction because the acid and the base will neutralize each other. And we've seen this before. Please write it down. Acid plus base, the products result in the products of salt and water. Let's do an example, and please write that down. 1 mole of aqueous sodium hydroxide reacts with 1 mole of acetic acid to form 1 mole of sodium acetate. So this is our salt, we'll come back to that, and 1 mole of liquid water. So our salt, as we know, forms from let's go with the acid first. And it doesn't matter which order they go in. It could be acid-base or base-acid. You'll have to remember how to recognize them. The acids have hydrogens, and we have memorized them, and then the bases often have hydroxides. So we take the back end of the acid, the anion, C2O2H3. Also, you know C2H3O2. It doesn't really matter how we write it. And then the metal or the cation from the base, right there. Okay, another example is your pancreas produces and secretes bicarbonate into the beginning of the small intestine to neutralize the acidic food coming from your stomach. So we know our stomach has a lot of stomach acid in it, and if you were to put that into your small intestine, it would kind of eat away a hole into your small intestine. So you have to neutralize that before it goes through the rest of your digestive system, and your pancreas actually produces bicarbonate, so like baking soda, basically. And that happens to neutralize it. So a titration is something I want to talk about. That is a kind of neutralization reaction. So it's a special kind of neutralization reaction that is used to determine the pH of an unknown solution. So what happens? It involves the controlled addition and the measurement of acid or a base of known concentration that will exactly neutralize a solution of unknown pH. So you have something you don't know its pH, and then you have something where you do know its pH, and so you put in the exact amount to neutralize it, and then you can figure out what was the pH of that other solution. So it also involves this thing called equivalence point, which is the point in a titration where the moles of hydrogen ions is the same as the moles of hydroxide ions. So that's when it is titrated. Okay, so we're going to be solving titration problems, and this is how you solve them. First thing, multiply the volume of the known acid or base, whatever it is, the known, by its molarity to find the number of moles. So if you have molarity, we know molarity equals moles over liters, so we multiply it by, we're solving for moles. So you multiply molarity by the volume, gives us moles. And if we know moles of one substance, we know we can find moles of a second substance because we've been doing that. We did that in Chapter 11, mole to mole problem. So you go from your known acid or base to the unknown acid or base. So do a mole to mole problem to find the number of moles of the unknown acid or base. And then we're going to go back to that molarity equals moles over liters, but this time we know the moles, we just found it out. We know the volume because we could measure it, and we divide those to get the molarity. So we started with the molarity and the amount of your known. We find the number of moles. We do a mole to mole problem to find our unknown number of moles, and then we use our molarity equals moles over liters to find the molarity of our unknown solution. All right, so let's do that. Please write this problem down. Calculate the molarity of a sodium hydroxide solution if 26.0 milliliters of the solution is needed to neutralize 16.8 milliliters of a 0.298 molar HCl solution. So please write that down and we'll go through solving it together. All right, now we're set to tackle this. So I know my first step is to multiply the volume of the known acid or base by its molarity to find the number of moles. So I'm going to be using the equation molarity equals moles over liters. My numbers aren't given in liters, so I'm just going to go ahead and convert those first. So I know if I have 26.0 milliliters of sodium hydroxide, that's going to be, I'm going to divide by 1,000, 0, 0, 1, 2, 3, just 1 0. 0, 2, 6, 0 liters of NaOH. And I have 16.8 milliliters of HCl. 16.8 milliliters HCl, again dividing by 1,000 would be 0.0168 liters HCl. Alright, so let's double check. 1, 2, 3. Okay, good. Then, as always, I'm going to write my equation. Molarity equals moles over liters. And then below that, I'm going to sub in my numbers. I know the molarity of my HCl, since I know the volume and the molarity, that is my known one, is 0.298 molar. And then I have moles, well I don't know that, I'm solving for that, divided by liters. Make sure to do the HCl one, 0.0168 liters. Now to solve for moles, I'm going to times each side by the liters, 0.0168 liters. Whatever I do on one side, I'm going to have to do on the other. Those cancel. And on the right, I'm left with moles. And then on the left, now is when we can grab out our calculator. I'm going to take 0.0168 and times it by 0.298, and I get 0.0050064. So let's see, it looks like I have 1, 2, 3, 1, 2, 3, 1, 2, 3 sig figs. So 0.00, I'm going to start counting sig figs now, 50, and it's 0.6, so I'm going to round that to 1. And then my unit for moles obviously is moles, and just a reminder, we're dealing with HCl. Okay, my next step, number 2, do a mole-to-mole problem to find the number of moles of the unknown acid or base. Number of moles? Well, we know to do a mole-to-mole problem, you need a balanced chemical reaction. So let's start with that. We know we're putting HCl and we're reacting it with sodium hydroxide. We're going to get, well, we take the back end of the acid and then the front end of the base, so sodium chloride, and we know it's going to form water. So water's liquid, sodium chloride is aqueous. And now we double check. I'm going to do chlorine first, 1 on the left, 1 on the right. I'll do sodium second, 1 on the left, 1 on the right. Now I'll do oxygen, 1 on the left, 1 on the right. And hydrogen, 1, 2 on the left, 2 on the right. It's balanced. It's a 1-to-1 ratio. That doesn't always happen, so you do have to find the balanced chemical equation each time. So then we're going to go with our mole to mole. So remember, when we're doing mole to mole, we start up with our original quantity. And yes, you are going to have to write out all these steps, even if you could do it in your head. Sorry. So down below, we're going to have to cancel that out. 1 mole HCl, so I can cancel out moles HCl, is 1 mole sodium hydroxide. So we end up with 0.00501 moles NaOH, because the moles HCl were crossed off, so we're left with moles sodium hydroxide. Wonderful. All right, step 3. Use the volume and number of moles of the unknown acid or base to find its molarity. So we're again going to use this equation. Molarity equals moles over liters. So we're trying to find molarity. We know moles of sodium hydroxide now because that's our unknown. 0.00501 moles NaOH over, what is our volume in liters? 0.0260. 0.0260 liters NaOH. And then on the third line, I want you to write your answer. So now is when you can grab out your calculator. We're going to do 0.00501 divided by 0.0260. And we're going to use our answer in how many sig figs? We get 3. So the molarity is 0.19, and then it's 26, so 3, and our unit for molarity is molar. Okay, so let's double check that we answered the question and we got a reasonable answer. Okay, did we answer the question? Calculate the molarity of a sodium hydroxide solution. Yes, we did. Is it reasonable? Well, we know from our balanced chemical equation it is a 1-to-1 ratio. So if it's a 1-to-1 ratio, if we have the same molarity, it should take the same amount. But we used less of the hydrochloric acid and more of the sodium hydroxide, which means the sodium hydroxide is a little less concentrated because it took more of it. And is it close to 0.3 but less concentrated than that? Yeah, it's less concentrated. It's about 0.2. It's less concentrated than the HCl. So we answered the question, got a reasonable answer. Good job. Okay, we know that neutralization and titration problems end in salts. So what is a salt? A salt is an ionic compound, so it has positive and negative ions. It is soluble in water, dissociates completely, it's an electrolyte, and it's made from the cation from the base and the anion from the acid. And then table 13.4 in your book has a list of some common salts that you should be familiar with. Okay, another important term for acids and bases is a buffer. A buffer is a solution that resists changes in pH, and it's made of a weak acid and its conjugate base. So an example is acetic acid and sodium acetate, HC2H3O2 and sodium C2H3O2. So I'm going to make a short little video to discuss buffers and finish up the chapter. I will see you then. Bye.